Today, we're diving right into something that's at the heart of pretty much every single program you've ever used. We're talking about the absolute basics of how code actually interacts with the world. It's a simple idea, but trust me, it's the foundation for everything else, so let's get into it.
So picture this for a second. A calculator. But this calculator has 0 buttons and no screen. I mean, it might be the smartest calculator in the world, it might know what 7 times 7 is, but how would you tell it to do the math? And how would you ever find out the answer? It would be totally, completely useless, right? Well, that little thought experiment is exactly why we're here today. So here's the game plan. We're going to start with why that imaginary calculator is so useless. Then I'll introduce you to a super powerful 3-step model that explains, honestly, almost any program out there. We'll break down how programs listen and how they talk back. We'll put it all together in one complete example, and then we'll wrap up with a blueprint you can use to understand pretty much any code you come across. Okay, so let's really explore that world without interaction. Just think back to our useless calculator. A program that can't communicate is really just a black box. It's just sitting there, running its logic all by itself, completely isolated. It's the ability to send and receive information that actually brings code to life. This really breaks down just how limited that is. You know, without a way to get information in or send results out, a program is just stuck. It can't ask you for your name, it can't do anything when you click a button, and it can never ever show you the final score. It's just a closed loop, which makes it totally useless and honestly pretty meaningless for us. So, how do we solve this? Well, it turns out the solution is this beautifully simple framework that, and I'm not kidding, is behind almost all programming. It's called the IPO model: input, process, output. Seriously, think of this as the secret recipe for how basically all code works. It's kind of like a 3-act play. First, you've got the input. That's the data, the stuff the user types in, the raw ingredients. Then you've got the process. This is the brain of the whole operation, where the program does its thinking, its calculating, its decision-making. And finally, you get the output, the result, the answer, the thing we were all waiting for. And this example just nails it. The user types in a test score, let's say 85. That's our input. Then the program does its job. It checks its little rulebook. Is 85 greater than or equal to 50? Yep, that's the process. And finally, it spits out the result on the screen, pass. That's our output. Simple, logical, and incredibly powerful. All right, let's zoom in on that first part of our model. We're going to focus on how programs actually listen. I mean, how do they get that data from us in the first place? So what is input really? It's just any information a program gets while it's up and running. It's the program basically pausing and saying, "Hey, you, I need something from you before I can move on." This is what makes software feel alive and interactive. Okay, time for some real code. This one little line is a perfect example of a program listening. It looks super simple, but there's actually a few important things happening here that we need to unpack. So, let's follow what happens. First, the program puts the message "enter your name" on the screen, and then it just waits. As soon as you type your name, say Alex, and hit enter, that text gets tucked away into a little storage box we call a variable, in this case, one called name. Now, here is a super important detail, especially if you're taking an exam. The computer always sees this input as just plain old text, what programmers call a string. Even if you type in a number, like 25, it sees it as text first. It's just the safest way to handle whatever a user might throw at it. Okay, so that leads to a really interesting little puzzle. What if we actually need to do math with a number someone types in? I mean, if the program sees your age, say 30, as just text, it can't do math with it. So we need an extra step. And here's the solution. It's a 2-step process. First, we get the input, say 30, and we store it as text in a variable called age text. Then, we use this special command, intconc, to convert, or what we call cast, that piece of text into an actual integer, a whole number. And now, finally, the computer can do math with it. This little conversion step is absolutely crucial. So the program has listened, and it's done its processing. Now, for the final crucial part of the conversation. How does the program talk back? How does it show us the result of its work? Output is really just any information a program sends out. It could be the answer to a math problem, a success message, or even an error alert. It's the program communicating back to us, closing that communication loop we started. And the most common way to do this in code is with a print command. Here, we're simply telling the program to display a friendly message to the user. Now, the really cool thing about print is how flexible it is. It doesn't just show static text.
It can take a fixed piece of text, like the word hello, and combine it with whatever is stored in our name variable. So if Alex is in that variable, the output becomes hello Alex. It builds the message on the fly. It's completely dynamic.
All right, we've looked at all the individual pieces of the puzzle. We've seen how programs listen with input, think with a process, and talk with output. So now let's put it all together and watch a complete conversation unfold between a person and a program.
And here it is, the whole shebang. This little chunk of code has everything we've been talking about. It asks for a score. It makes a decision based on that score, and then it reports back the result. This right here is a complete working program.
Let's trace the journey step by step. First up, input. The user types in a score, 95, and the program immediately converts it from text into a number. Next, process. An if-else statement acts like a bouncer at a club. It checks the score. Is it 50 or higher? And decides if the result is pass or fail. And finally, output. The program prints out whichever result was chosen. See? Input, process, output. The whole model, right there in that tiny program.
Okay, let's zoom out and lock in the most important points from all of this. Think of these as your personal blueprint for looking at and understanding pretty much any program you ever come across. So let's just nail down the 4 big takeaways. 1, input is how we feed data to a program. 2, output is how the program talks back to us. 3, and don't you forget it, that input almost always comes in as plain text, a string, and you usually have to convert it. And finally, the big one, almost every program you will ever see follows that simple, elegant input-process-output model.
And why is this so important? Well, this quote really says it all. Knowing how these 3 parts fit together isn't just some abstract theory. No way. It is a practical, must-have skill. It's exactly how you'll be expected to analyze code and solve problems.
So we've seen it. Input, process, and output. It's the basic rhythm of all code. It's how our digital world communicates. And even though the model is simple, it's the blueprint for solving an infinite number of real-world problems. So I'll leave you with this question. Now that you've got the blueprint, what's the first problem you would want to solve with it?